All right, we were talking about parallelograms, right? This lesson right here is going to look very, very similar to what we talked about before. So it's kind of a good lesson because we're going to do a little bit of review. Um, but it is a little different. Let me grab this parallelogram right here. I'll copy that and paste it. But there's a slight difference. There's a slight difference between what we're doing today and what we did yesterday. It's a subtle difference, but it is a difference. Um, Before, what we did is we learned, by the way, I don't think I ever showed you the little symbol. Well, I probably did when I showed you the video, right, when the video was shown to you. For this, like if we call this parallelogram, instead of writing out the word parallelogram, we draw a little parallelogram symbol like that. Kind of like triangle, right? We've done that a bunch of times, haven't we? Put the little triangle symbol, the line segment symbol, all that kind of stuff. Well, this is the symbol for parallelogram, right? Looks like a little parallelogram. And then how do you name it? You can use any of the four letters in any order. Well, not in any order. I shouldn't say that. If you start with one letter, you have to go, what do I always say? Around the horn, right? So if I start with A, I could call this what? A, B, C, D. Or what else could I call it if I started at A? A, D, C, B. I cannot call it what? A, C. Right, I can't go across like that. If I start here, I got to go one way or this way. You follow me? If I'm going to call it. So I could just call it A, B, C, D if I wanted to. I don't have to start at A, though, do I? I could have started at C. But if I started at C, what would I call it? I'd call it what? C, B, A, D, or I could call it C, D, A, B. Got it? Okay. It's probably a little bit nicer if I just call it A, B, C, D. Would you agree? All right, so that's a parallelogram. Now, what we learned before was, okay, we told you that this was a parallelogram. I said that this thing right here is a parallelogram. So if it's a parallelogram, what must be true about all the sides? Well, the sides must be parallel. They must be equal, right? They must be equal to each other, the opposite sides. The angles, opposite angles must be equal. The consecutive angles must be supplementary. Diagonals bisect each other. Remember all that stuff? Okay, that's if it was a parallelogram. So if I told you it was a parallelogram, I could tell you all that stuff about this. But what if I didn't say it was a parallelogram? What if I just drew the picture, drew the points right there, right? You know, I put the points in, or the letters, I labeled all the vertices. If I didn't say anything about it, could you look at this and say this is a parallelogram? You could? Go. Could I say it's a parallelogram just by looking at it? No, I can't say it's a parallelogram because I haven't been told it's a parallelogram. Kind of looks like one, doesn't it? All right, but it's not because, or I can't say it is because I don't know anything about it. I don't know that the opposite sides are parallel. I don't know that the opposite sides are equal or anything like that. So I can't say it's a parallelogram. But what if, and do you see the difference so far in this and what we did before? Before, I told you that, yes, this thing is a parallelogram. Okay? That's what I told you before. This is a parallelogram, right? I had it up there. I had that little symbol up there. But this time, I'm not telling you it's a parallelogram. You just see the picture, and that's all you see. Okay? But, watch this. It's just a quadrilateral. It's just a four-sided figure. I don't know it's a parallelogram, but what if I knew this? What if I knew those two sides were parallel? Does that make it a parallelogram?
Yes.
Just these two sides parallel? Mary, what do you think? No, for what reason? What would make it a parallelogram? If these two are parallel, that's not enough to say it's a parallelogram. The other two, right, the other two have to be parallel, don't they? So these two have to be parallel as well. Now, what if I told you that information right there? Is that enough to say that this is a parallelogram? Absolutely, okay? Do you see the subtle difference between what we did before and what we're doing today? Remember, today I didn't tell you it was a parallelogram to begin with, right? All I told you is that the two opposite sides are parallel. If that's true, that's all you need to know, and then you can say it's a parallelogram. Do you see that? So I didn't tell you it was a parallelogram. All I told you was AB and DC were parallel, and AD and BC are parallel. If I told you that information, that's enough information to say that this now is a parallelogram. You follow me? So basically what we said before was this. If it's a parallelogram, watch, if it's a parallelogram, then all this stuff must be parallel, right? Then AB is parallel to DC, and what else? AD is parallel to BC. All right? So if it was a parallelogram. But what are we saying today, though? We're switching the if and the then, aren't we? We're saying what? If A, B, and DC are parallel, and if AD and BC are parallel, then guess what this whole thing is? It's a parallelogram. What do we call that when we change the if and the then around? We call it the converse. We've been doing that all year long, haven't we? Taking a theorem and then going if then, but then we switch the if and then around, and both of those are going to be true. All right? That's when they're converses of each other. And that's what we're doing today. Today is just basically the converse of what we did before. All right? So we don't know that it's a parallelogram right now. All right, we don't know that it's a parallelogram, but we do know some things about this. We do know that the opposite sides are parallel. Got it? All right, let's get rid of the parallel stuff. All right, let's say we don't know that the opposite sides are parallel. Nobody told us that it was. But what if somebody told us that this side was equal to this side? Is that enough to say that this is a parallelogram? No. What else do you think you need to know? That the other two are parallel or equal to each other. Not parallel, but equal. See the difference? So if I told you that AB was equal to DC and I told you that AD was equal to BC, then what do you think you could say about this whole thing? It's a parallelogram. So if it's a parallelogram, what do you think now I could say about A and C? That they're equal. What do you think I could say about B and D? They're equal. What do you think I could say about the diagonals of this thing if I put them in there? That they not equal, no, they bisect each other, right? They bisect each other, okay? Do you see what we're doing here? So again, I didn't tell you that that was a parallelogram to begin with, but I did give you some information about it, right? And then from that information, you could tell that it's a parallelogram. Do you see where we're going with this? Watch this. This next part should make a little more sense to you now too. What else do you think? What else do you think if I knew was true about this would make it into a parallelogram? What if I said angle A was equal to what? Angle C. What if I told you that they were equal? That's not enough right there to say it's a parallelogram. What else would you have to know? The D and B. Right. So if I knew this, again, I don't know it's a parallelogram to begin with, but I do know that angle A equals angle C, and I know that angle B equals angle D. Is that enough to say that it's a parallelogram? Absolutely. So yeah, so if that stuff is true, if I was given this information right here, right, they may not put the arcs here. They might say this is 120 and this is 120, right? And this is 60 and this is 60, right? They might not put the arcs there, but you could see that they're equal to each other. So if that's true, that's enough to say it's a parallelogram. So if I said that the opposite angles were equal to each other, then this thing must be, guess what? A parallelogram. Now, if it's a parallelogram, there's a whole bunch of other stuff that's true about it too, right? So now I made it into a parallelogram. What could I say about the opposite sides? Well, they're parallel to each other and they're equal to each other, right? And these two opposite sides are parallel to each other and equal to each other. And I also know that the diagonals are, they bisect each other, right? There's a lot of stuff I know. I also know that these two angles right here, if this is a parallelogram now, I can say that they're consecutive angles and they're supplementary, right? You getting the hang of this now? It's kind of like what we did yesterday, isn't it? It's just a little subtle difference. We just changed the if and the then around. All right? What if I told you this? What if I said that... Now, if that's all I drew, is that enough to say that it's a parallelogram? No, because I haven't said anything about those diagonals, have I? Okay, but what if I'd said this? Let's make this E right here. What if I said that this and this are equal, and this one are equal? Now the diagonals bisect each other, don't they? So guess what must be true about this whole entire figure ABCD? It's a parallelogram now, isn't it? All right? So if the diagonals bisect each other, that means this whole thing is a parallelogram. And again, I know it sounds like a broken record here, but if it's a parallelogram, what must be true about the opposite sides? They got to equal each other, and they also have to be parallel to each other, right? I also know that the opposite angles are equal to each other. Okay, I know that consecutive angles are supplementary. I know all that stuff. Just because I knew that the diagonals bisected each other, that tells me a bunch of stuff about this. It tells me that this now is a parallelogram. I know for a fact it's a parallelogram. Getting the hang of this? Cookie, getting all this? It'd be better if you looked up here instead of out there. At least try to pretend you're watching. Okay. Let's see. Now there's one other thing. I'll tell you what, let's get rid of this whole diagonal thing. Oopsie daisy. Don't want to get rid of that. There we go. All right. Here's something that's a little different than what we did before. What if I told you that this was equal to this? Is that enough to say that this is a parallelogram? No, it's not. Okay, but here's something a little bit different. This is a little different than we talked about before. What if I said that just these two, I don't know anything about these two left and right sides right here. I don't know anything. I just know something about the top and the bottom. I do know that they're equal to each other, and I also know that they're parallel to each other. Okay? That right there, I don't have to know anything about this left side and right side. I don't have to know anything about the angles. All I know is that these two are parallel and these two sides are equal to each other. The same two sides, right? The same two sides are both equal and parallel. That right there is enough to say that this is a parallelogram. Okay, I don't have to know anything about A, C, D, and B. I don't have to know anything about this side and this side. If all I know is on one of these sides, this side is both, what? Two things. Parallel to each other and what else? Equal to each other. If I know that, that's enough to say it's a parallelogram. And again, for about the 5th time today, if it's a parallelogram, all that other stuff is true about a parallelogram. Okay? The diagonals bisect each other. That means that this side and this side are equal, right? And it also means that this side and this side are parallel to each other. All right? If I've established that this is a parallelogram. So this is all you need to know as far as that information right there. If I know that one pair of opposite sides is both parallel and equal to each other, that makes that thing a parallelogram. Does that make any sense? All right. And I think, let me just double check my book here. I think that's pretty much it. Let's do an example, okay? And I'll show you what the questions are going to look like and the kind of stuff that you have to do here. And we got a few minutes. You know what I forgot to do last period? It was my planning period, and I forgot to copy off the worksheet for you, but I can do that real quick. As soon as I do this, let's see what I want to do. I want to reflect it. There we go. Looks a little bit more like this example I want to give you. So watch this. If this is 56 degrees, and this is 5y minus 26 degrees, this one down here is 7x degrees, and this one is 4y plus 4. 4y plus 4 degrees. Yep. All right. Now, we don't know this is a parallelogram right now. They don't tell us it's a parallelogram, okay? But this is what they ask. They say, find x and y so that the quadrilateral is a parallelogram. So I want to find out what x has to equal and what y has to equal in order to make this thing into a parallelogram. I don't know what's a parallelogram right now, all right, but I do need to make it into a parallelogram. So what did we just say? What's true about the opposite angles? Okay, right. In order to make this a parallelogram, these two opposite angles have got to be equal, right? These two have to be equal, and guess what else? These two right here have to be equal. You follow me? All right, in order to make it into a parallelogram. Again, it's a very, very subtle difference between what we did in like section 6.2 and what we're doing now in section 6.3. Very subtle difference. To you, it may look like it's the exact same thing, but it's a little different. So what we're doing here is we don't know it's a parallelogram, but if I took these two and set them equal, and if I took these two and set them equal to each other, that would make it into a parallelogram, wouldn't it? All right, so let's do that. So 7x equals 56. So what's x equal to? So x would be 8, right? So if x is equal to 8, that gives me halfway there, doesn't it? All right, that gives me one set of angles equal to each other. What about the y? What do I do with those? Do the same thing. Set those equal to each other. So I go 5y minus 26 equals 4y plus 4, and then we just do the math. Subtract 4y from both sides, and that gives us a y. You see that without actually showing it? Right? And then you do what? Add a 26 to this, and what do you get? 30. And so if y is equal to 30, and if x is equal to 8, that's going to make this thing into a parallelogram. Again, remember, we didn't know it was a parallelogram to begin with, but if x is equal to 8, and if y is equal to 30, then this would be a parallelogram. Let me just show you. So if x is equal to 8, what's this angle right here? 7 times 8 is 56. Are these two opposite angles equal? Yeah, it is. Okay, what's going to make these two opposite angles equal? Well, y is equal to 30. So 4 times 30 is what? 120 plus 4 is 124. Let's see if this angle is the same exact thing. And if it is, then that thing's a parallelogram, isn't it? 5 times 30 is what? 150. And 150 minus 26 is 124, just like it's supposed to be. So look, y made these two angles equal to each other, didn't it? Okay, y equals 30 made these two angles equal. X equals 8 made these two angles equal. So if the opposite angles are equal, guess what this thing is? It's a parallelogram. Make sense? The math is really exactly the same as what you did before. Okay, I could have said, okay, this is a parallelogram, solve for x and y. That would be, again, it's a very, very subtle difference. Very, very subtle difference. But there is a difference. All right? I think that covers it. I think that's good enough right there to do. And let me run out and get you a worksheet real quick, and then you'll be good for tonight.